Now in this part, I am discussing about the temperature variation of frequency with respect to tension. Implies if a guitarist make more temperature in its string by taking certain amount of heat from the heater coils, or initially he practiced when the string, the tension and temperature becoming a particular position, then what will happen if the density and the linear coefficient of temperature expansion taken as a constant for a string. We are taking a string like this and giving certain amount of tension into it, and whenever a certain amount of tension is changing with respect to temperature, we can modify that law with respect to the elasticity and temperatures, such as we are getting elasticity of a string is T upon A delta L by N, as we know. This Young modulus giving you tension Y A delta L upon L, and if you take delta L as linear expansion of the string L alpha delta T, so we are getting T equal to Y A alpha delta T. That is, this tension with respect to this temperature difference is giving such equations. If we put this equation to the velocity equation T by mu and input T, we are getting Y A alpha delta T upon pi rho. Cancelling each other, we are getting a simple law 1 upon 2L Y alpha delta T upon rho. Implies that if increasing of temperature which takes place, definitely to the power half of it is giving you the proportionality of the frequency of the object in a system, because as we know the frequency was also under root of T variabilities. So in such situation, dF by dF percentage change of frequency with respect to temperature will follow such equation half times of temperature variation, that is dt by T percentage. Such like question usually used to come in IIT level. Certain question you will get in the variation of densities also. In this situation we are not considering density as a variable function with respect to temperature, but if density also a variable function, then in such a situation dependence of the equation must be there, and such question become more good when you go through it. I am giving such like a question on this situation, such as we are taking a material changing its density by the following equation: rho T equal to rho naught K x square, where x is the variable function with respect to temperature, and tension in this system following equation, that is Kx. Again x is a variable function with respect to temperature. What will be the percentage change in the frequency if the temperature function increases by 9%? This is a simplest question, but when you go through your IIT paper, you will see that question becoming more tough, because function variability equation is completely unpracticable to the students. So for a good student, they must know how many types of question usually used to come from a particular concepts. I am giving a simple question. Whenever we will go through the question classes, we will make more number of good questions. Now in this question it is given that density variability with respect to temperature function as a rho naught Kx square, tension variability with respect to temperature function as a Kx. What will be the frequency percentage change? So definitely we have to take that law, that is 1 upon 2L under root of T, that is as Y alpha delta T upon rho. If this function variability is here, so two equation we are getting. One is about frequency is about of temperature function. Temperature function is here, you are getting x. As we know, percentage will be half with respect to frequency, so it will be half of k x to the power half, or k as a constant. Sometimes it will be cancel each other, you will see that matter. And then when you go to the percentage of the density, it is again half but minus. So definitely it will be your changing variability as k to the power half of x. So in such a situation, you will see that variabilities will give you a normal relation function as is 1 upon x to the power half. That is x to the power minus half as a percentage. So that means we can write down that is as a temperature function, it is dt by t minus of half percentage. In such question, you need more practice to understand in brief. I discussed this thing in very brief manner, but a good student will understand definitely how you get this answer. But to get such question, we have to go through the question classes. But without knowing the real fact of this equation, variabilities and their perimeters, we cannot go through these questions. Another type of question they can give you on such a way that if the one load is hanged of 10 kg through a string, now another 10 kg is given to it, then what will be the change of frequency? If we think that the only length variation takes place with respect to the loading. In that particular situation, we will discuss about the L, the length function. So I will discuss that type of question also. Other question may become from this equation, if more than one string is branched together or a string stretched, what will happen? In these two situations, you have to think two parts. One, if the string stretched, then definitely stretching of the string can give you only the volume as a constant. Radius will decreases, length will increases, definitely volume must be constant. So whole equation must be converted to the volumetric equations, and the volume equation will give you the frequency. But if it is branched, if one wire is placed to the other wires to the place to other wires, and it is becoming a thick wire, such as transmission line wire, and if you like to vibrate it, what will happen there? In this situation, we definitely go through the concept of mass analysis, that is mass per unit length, that is your mu, from where this equation used to come, that is 1 upon 2 Lr pi T upon pi rho, that equation came, we will consider that equation. So such modified equation I am giving to you for the question classes.